Totoo ba? Totoo ba, Edwin? Aminin mo!
In 1929, Edwin Hubble published his article about the relation between the distance and the recession velocities of the galaxies, which in English simply means the expansion of the universe, with dark matter, dark energy, and billions of galaxies. In his study, the ones that are far move faster, and the ones nearby move slower. This is due to the aforementioned relationship wherein the velocity of a galaxy is proportional to their distance from the Milky Way. On the y-axis is the velocity of the galaxy obtained from the spectrum, and on the x-axis, the distance to that galaxy. Flashback to our math classes, the equation for a line that passes through the point 0, 0 is y is equal to mx. M is the slope of the line. H sub 0, the Hubble constant, is the slope of the line that relates the distance of a galaxy to its velocity. If the universe is static, there should be no correlation between the distance and velocity. The usual analogy used is that of an explosion where the fragments of shrapnel produced are moving with a range of velocities, and the most distant object from the source of the explosion have the largest velocities. This source, a singularity, takes us back to the occurrence of the Big Bang Theory, where the Hubble's law is the direct consequence of it. There's also this phenomenon called the Doppler shift, an implication of the Hubble's law. How though? Suppose you hear a siren. As it nears you, it's louder, with a higher pitch, and upon its movement farther, you hear less. The same way happens to light waves. Doppler effect describes the frequency changes of a sound or even a light wave produced by a moving source with respect to the observer's point of view. Waves emitted by an object traveling towards an observer get compressed, resulting to higher frequencies. On the other hand, waves emitted by a source traveling away from an observer get stretched out, resulting to lower frequencies. When we stargaze, we sometimes see red twinkling stars. Astronomers observe distant galaxies through the colors they project. Objects traveling towards us results to blue light. Objects traveling away from us results to red light. This phenomena is called redshift. Wavelength is stretched. Light is seen as shifted to the red part of the spectrum, and this stretch indicates that the object is moving away from us. We ought to think that these discoveries make us closer to the answers we are looking for. Nevertheless, these discoveries make us realize that there are a lot of mysteries to uncover and bring to light.